Before we graph the tangent function, we're going to look at some general graphing techniques. Specifically, we're going to focus on the locations of zeros and asymptotes. These ideas are usually covered when graphing rational functions, so we won't go into the full detail here. Suppose we have a function of the form f of x equals n of x over d of x, where we've cancelled out all the common factors. The zeros of f of x correspond to the zeros of the numerator n of x, and the vertical asymptotes correspond to the zeros of the denominator d of x. For example, consider the graph of f of x equals x minus 2 times x plus 3 divided by 3 times x plus 1 quantity squared. The numerator is 0 at x equals 2 and x equals negative 3, which is where we have zeros of the function. And the denominator is 0 at x equals negative 1, which is where we have a vertical asymptote. Since tangent of x is equal to sine of x over cosine of x, we can apply these ideas to get a reasonable sketch of the graph. We will start with the zeros. The zeros of tangent of x will be the zeros of sine of x. These happen at 0, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, and so on. So we will plot these zeros for the tangent function. The asymptotes of tangent of x will be at the zeros of cosine of x. These happen at plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, and so on. We will draw vertical dashed lines to represent the vertical asymptotes for the tangent graph. To determine whether we are approaching positive or negative infinity at the asymptotes, we need to think about whether the sine and cosine functions are positive or negative on each interval. Because the sine and cosine functions are periodic with period 2 pi, we will just need to look at the intervals between 0 and 2 pi and can repeat from there. These sketches allow us to quickly see whether each function is positive or negative. For the 4 subintervals in the sine function, we get positive, positive, negative, negative. For the 4 subintervals of the cosine function, we get positive, negative, negative, positive. And then the pattern continues for both of these. The first interval is from 0 to pi over 2. Both functions are positive here, so we know that the graph will approach positive infinity on the left side of pi over 2. On the interval pi over 2 to pi, sine is positive but cosine is negative, which means that the tangent will be negative, and so the graph will approach negative infinity from the right side of pi over 2. We can continue this logic to fill out the rest of the graph. From this information, we can get a rough sense of the shape of the tangent function. Notice that the tangent function is periodic with period pi instead of period 2 pi. In fact, the fundamental period for tangent is negative pi over 2 to pi over 2. We would say that this is one branch of the tangent function. Here's the chart of key values for the tangent function. Notice that the values at plus or minus pi over 2 are undefined. This is just a reminder that you have asymptotes there. Once we have the key values, we can graph the transformed versions of the tangent functions using the same techniques as we used for the sine and cosine functions. The only difference is that when determining our fundamental period, we will set the argument equal to plus or minus pi over 2 because that's the fundamental period for the tangent function. Example: graph y equals 2 times tangent of x over 2 minus pi minus 2. We set the argument equal to plus or minus pi over 2 and solve for x. This shows us that the fundamental period is from pi to 3 pi. The midpoint of this interval is 2 pi, and the midpoints of the new intervals are 3 pi over 2 and 5 pi over 2. We can now take the y-coordinates and substitute to get the transformed values. We multiply the base values by 2 and then subtract 2. This gives us points and asymptotes that we can plot and use to sketch the graph. Lastly, we can use periodicity to graph the other branches of the function. These reference points don't correspond to well-defined features as they do for the sine and cosine functions. Because of this, it is especially important that they are graphed carefully and labeled so that it's clear that you know what you're doing. In the next video, we will talk about graphing reciprocals of functions and use that to graph the cotangent function.